For this vodcast, please have note pages 24 and 25 in front of you. This is the end of our organic reactions vodcasts. We're going to take a look at two organic reactions. We're going to take a look at fermentation and polymerization, and there's two branches that come off of polymerization, the addition polymerization, and what's located on the next page is called condensation polymerization. Okay, so let's start up with fermentation first. Now, in dealing with fermentation, what you have is the production, right? So your products are going to include an alcohol and carbon dioxide, which is produced from a sugar. So this is kind of like a decomposition reaction. In this specific case, yeast contains an enzyme that breaks the sugar or the glucose into carbon dioxide and ethanol. Ethanol being a portion of an alcohol, obviously. You must know this chemical reaction. You're going to see this. I would guarantee that you're going to see this type of chemical reaction, fermentation, on the Regents exam. You won't have to draw it, but you're going to have to guess, predict what's involved here. All right, this type of process is used in the making of grape juice, which over a long period of time of fermentation produces wine. Also used in the making of champagne as well. All right, so let's take a look at the formula that's involved here. Like we said, we start with just the basic sugar, glucose, sucrose, whatever it may be. And because of the enzyme, yeast, that's involved, what's produced is an alcohol, which is going to be represented with an OH chain attached to it, and of course, carbon dioxide, CO2. All right, so an example might be if you have some sort of sugar molecule all by itself, let's go C6H12O6. We have an enzyme that's involved as a catalyst. Like we said, that would have been some sort of yeast product. And what's going to be produced is C2H5OH. Right, there's our alcohol portion, and also naturally carbon dioxide. And this is the material that's released whenever you open up a bottle of champagne or beer or any type of alcohol drink, is that you get the carbon dioxide that's being released. So when you look at this type of reaction, you just want to see that you basically have a decomposition reaction taking place here, where you have sugar all by itself, and it's broken down into an alcohol. In this case, this was an ethanol, and carbon dioxide. Pretty straightforward, pretty simple, I believe. All right, the next type of organic reaction is called polymerization. All right, and just to break down the term of polymerization, poly stands for many, subunits, and we'll talk about how these many subunits can come together. What you're going to see in this whole process of polymerization is something that starts out with many small molecules is going to be developed into a very large molecule itself. So what we're dealing with is the formation of large molecules called polymers. These are organic compounds made up of chains of smaller units, covalently bonded together. Right, so we're covalently bonding them together. These are called monomers. Small molecules, monomers, that are joined together to form a larger molecule itself, to form a larger polymer. Polymers are large molecules with unique characteristics. Some examples of natural polymers are starches, cellulose, Proteins, some examples of synthetic made polymers are plastics, nylons, rayons, polyester, different types of rubbers as well. Okay, so let's focus on the first type of polymerization, and that's called the addition polymerization. With the addition polymerization, we are going to be dealing with unsaturated hydrocarbons. All right, so we're going to be looking at hydrocarbons that are double bonded, maybe in some cases triple bonded. All right, the example down below shows two double bonded monomers. All right, so it's unsaturated monomers joined by breaking their double or triple bonds to bond with one another. All right, so what we're going to be doing is we're going to be making long chains. All right, so if you have two ethene hydrocarbons, one here, and what happens with the whole addition polymerization is that these bonds are broken and all the carbons, 1, 2, 3, 4 carbons are joined together. Right, here's our 4 carbons that are located with the two ethene molecules, and you are combining also the 8 hydrogens as well. Right, here's your 8 hydrogens. Right, they are added here, 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 and along the bottom as well, and they're all also located here too. Because of the breaking of the two double bonds, we also pick up another hydrogen, which is going to be located at both ends. So this would be a hydrogen here as well, and a hydrogen here as well. So as you can see, you take the two monomers are broken apart, mono obviously being individuals or one, and what's produced polymers, which is many, like we discussed up above in the example of what polymerization actually represents. All right, so this is addition polymerization. Now on the next page, in the last page of this unit, we have condensation polymerization. All right, when you hear the term condensation, what I'd like you to do is think of water. So what you have here is monomers joined by removing water molecule. All right, we're dealing with a hydroxyl group here, OH group, and either an ether or ester linkage joined to create water again. All right, so here's what happens. We have a very complex looking organic reaction here. All right, a couple of pieces we want to identify. This right here, off this very large chained ring organic compound, this is our carboxyl. Right, this is considered to be very, very acidic. Another piece right here shows our alcohol. All right, and what's going to happen with this process is that the H from here and the OH from here are going to join together, and what you're going to have is the removal of water. Right, so when these come together, right, what you're going to have is the subtraction, the removal of the water, right here. And what's going to be produced is the combination of these two monstrous looking organic compounds, specifically the carboxyl group and the alcohol group. At those two different sites, that's where they're going to be joined together. All right, so you can see let's see if I can highlight this. Let's circle it and box it instead. This O right here, where the hydrogen has broken off of, and the CH2 right here are going to be joined together. All right, so now down below you can see the O is here, and the joining of this alcohol is right here to bring the two together. That's where this bond comes from right here. All right, once again, a very complex looking polymerization. You won't have to draw this. You'll just have to be able to identify. And like I said, when you see condensation polymerization, think of water itself.